Hey guys, again, so sorry that today has been tight. I know I'm on a tight schedule today, and even my flight alone is 12 hours, and so I don't know. I can't guarantee if I can make it. I'll see what I can do, but I don't know. So what I did is I prepared this long video to compensate, where I didn't prepare a high-level proposal. That's not the purpose of the video. This is only to solely address the 4 technical questions that you asked in the email, and basically so that you guys can discuss and assess my technical proficiency and see if I'm a backend fit, to the role, the second engineering backend role that you guys are looking for. So without further ado, I'm going to show you guys this demo. I'm going to show you guys a FastAPI project was made to address 4 specific questions that you guys asked in the email. Let me first start with the setup. So it's a bare FastAPI project, a simple app entry point. I run it with Uvicorn, and then if you look at the logs here, you'll see that. Just a second. If you see the logs, and I'm capping that on a single. Cap the default draft pull to 1 worker. And I'll explain this why later in the async versus sync section. But the important thing to notice is that I understand why you guys are looking into FastAPI library because of how easy it generates docs. Because if I go to the docs page in the browser, I instantly get a Swagger UI interface out of the box. It's a huge productivity boost compared to other frameworks where you have to wire up the documentation manually, right? And then some people might ask, like, why? And again, you can see here, currently I'm wrapping up this FastAPI in Django using ASGI. And again, people might ask, like, why isn't Django more production ready, where it has the admin and ORM built in? Well, FastAPI is definitely lighter and faster to prototype with, and basically was designed with Async in mind, while Django is heavier and is designed for synchronous by default. They can actually be combined. We can actually combine the best of both worlds. FastAPI mounted into Django for APIs and a Django used for templating, but here I'll be focusing purely on the FastAPI side, right? Now let's move on to the Pydantic models, which is the second question that you guys asked. I'm going to show you guys the models .py file. There we go. So here I'm creating 2 different models: UserCreate, UserRoute. UserCreate kind of defines what inputs are valid when someone creates a user. For example, the email field must be a valid email. The full name has to be a string, and then the isAdmin flag must be a boolean. UserRoute describes what gets returned, right? So, and again, the beauty of that of the Pydantic models is you have that validation thingy at the very bottom here. The validation of what was the rules that we're creating for excuse me, for UserCreate and the UserRoute, right? So I'm going to test this out. Okay, I'm going to test it out and on the create user. Okay, now I'm going to send a success one first, which is I'm going to simulate a success scenario, okay, where let's make this a valid email, and then you'll see, there we go, right? So success, right? And then beauty of Pydantic models is that it will give you the exact error message on why things are breaking. It will throw you that 422 error, so that you know what to do, so that you don't have to manually design the error logs based on the error codes and so forth. However, again, I would say the pros of Pydantic is that it's first-class citizens and the framework is designed around them, but the downside is will be tightly coupled to Pydantic. So that's why, in my opinion, in my previous project, I normally would either make a hybrid of Pydantic and use certain things for edge cases that Pydantic doesn't cover. I would use Django REST Framework serializers, which gives me more control on the scope that Pydantic doesn't cover. Okay, so yeah, again, so we are using the best of Pydantic. We're also using the best of Django REST Framework serializers. So that's what I would normally do if we scale things. Okay, now moving on to the third part of the question, which is the difference between sync and async, and how is it handled, like, what's the difference, right? And you can see here I've created two endpoints, sync slow and async slow, and sync endpoints are pushed into the what's it called, a thread pool, so that they don't block the event loop, and the sync endpoints run directly on the loop. Okay, so created two test endpoints, one sync that calls time sleep, and then one async that calls await asyncio sleep too, as you can see here in the there we go. So this one using asyncio sleep, this one is using time sleep. To make the difference clear, this is why earlier I was basically capping, limiting the thread pool to a single worker. That means if you hit the sync endpoint with many requests at once, they'll be queuing one over another. And then async calls, by contrast, can overlap and run concurrently. So, and to show the impact of that, to show a difference, so let's run this script that I've created basically to simulate what's the difference in terms of performance between sync and async, right? Excuse me. So watch the spinner. It will show the requests while the requests are in flight. For the sync endpoint, now we're sending 5 requests with concurrency 5. So you can see here, sync took 10 seconds while the sync took 2 seconds. And then let's compare it with real IO. I added 2 endpoints that call in an external delay service with HTTP bin. One uses the blocking request library, the other one uses the non-blocking HTTPX async client. If I run that, you will see, so this is like a real browser based environment on the internet connection, so it's taking 18 seconds. This is local, right, by the way, which doesn't really resemble what the real production environment would look like. So this would resemble more. So you can see how fast does a sync perform as compared to sync. So that demonstrates perfectly why sync matters. It scales with concurrent I/O without tying up threads. And at low concurrency, right, sync can look like they're fast as a sync. However, and that's why sometimes some teams still stick with using with multiple sync Django apps. The real difference only shows up, that bottleneck only shows up when you scale the number of concurrent requests, especially when you're bound by I/O like database or API. Okay, now to the last part of the question is the I think you guys were asking about AWS run pod and so on. How do I handle those integration work? So in my FastAPI app, I already added some endpoints. Excuse me, I'm having some cold. And basically there's a background endpoint that logs messages to S3 using the background task feature. If the AWS environment variables are not set, it just no up, so the app still runs fine locally, right? So because right now I'm not tied to any, right now I don't have any paid access right now with RunPod or AWS, so that's why you'll see me building it here. So there's a RunPod echo endpoint, which is structured like a pod inference API, and basically it runs as a mock here. And there's a hugging phase sentiment endpoint, which calls the inference API if I provide a token, or returns a dry run message if not. because I don't have paid access to any other stuff, so I'm simply gonna show you guys later Hugging Face because it's free. There's an API key there. This is just to show you this design, make it easy to run. So you can see here settings is not expecting anything on the env file, and so it's optional. It makes it easy to run locally without depending on paid service, but the wiring is already in place for cloud deployments, right? So so let me just show real quickly like how would that looks like if I run something to Hugging Face, right? So I would basically run this and then what's gonna happen is that it's gonna take that bird model that I specified in the Hugging Face here, basically the bird model, and what it's gonna do is just a second, so it will return so it will do a sentiment analysis based on the bird model to see if like what's the likeliness of you know, that basically it's a positive sentiment. If it's 5 stars, you know, what's the score likeliness that is a 5-star equivalent, or if I'm trying to say something negative, you can see there's a very low score here. So in practice, I would put this into GitHub Actions workflow with CI checks and container builds. That way, tasks and mock calls run on every pull request. Real API calls only happen in production with secrets enabled. The philosophy is to keep one code path that works in both development and deployment, with environment configuration, you know, determine whether it hits mocks or live service. So I hope that these 10 minutes or 11 minutes video is sufficient to show you guys what I'm capable of, and if you guys still want to do that interview, I'm open to that. But if you guys are rushing, I'm hoping that this video would, you know, would be sufficient to show one, technical proficiency of what I'm able to do. Second is if I'm gonna be a backend fit for you guys. Okay, so all right, hope you guys, I hope I be able to show you, you know, be able to see you guys soon. And yeah, again, so sorry for my tight schedule today. Yeah, and yeah,